In today's extension activity, we're going to combine two different objectives. We're going to combine 1.1, finding domain algebraically, with 1.6, composition of functions. Let's start by reviewing the rules for finding domain algebraically. The first thing you need to remember is if you have a fraction, such as below, your denominator should never equal 0. The next thing you need to remember is that if you have a radical, also known as a square root, that can never be a negative. And then finally, if you have a square root in your denominator, that cannot equal negative or be 0. As long as you keep these three rules in mind, you can always find domain algebraically. And then, of course, composition of functions. When you see this type of notation right here, what this means is the second function is going to be substituted for x inside of the first function. So another way to write this notation is as follows. Let's go ahead and work out an example problem. So here, this question is asking for me to find the domain of this composition given these two functions right here. So the first thing that we're going to start by doing is composing the two functions and finding our final equation. So I'm starting by substituting in the blue equation, which is g of x, for all of the x's inside of f of x. And I'm going to make sure to write this out in color so that you can see which equation is being substituted inside of which equation. So here I'm replacing the x in the radical with x plus 3. And then in my denominator, I'm replacing the x again with x plus 3, and that's going to become squared minus 1. So this is just the first step. I've substituted in g of x for all of the x's inside of this equation. So this x got replaced with x plus 3, this x got replaced with x plus 3, and now I'm going to go ahead and clean up this equation as much as I can. So in the numerator, there isn't really anything extra for me to do, but in the denominator, I see this squared sign right here, so I'm going to go ahead and FOIL this out. So I'm going to end up again in the numerator with x plus 3, nothing special is going to happen there. And then in my denominator, if I FOIL out this equation, I'm going to end up with x squared plus 6x plus 9. And then I also have to remember to bring down that 1. If you need review on FOILing what I just did, I'm going to write it out to the side. I'm going to put it in blue, x plus 3 times x plus 3. And remember, FOIL is always first, outside, inside, last. So this gives me x squared plus 3x plus 3x plus 9, which then combines to give us this final equation right here. So I'm going to go ahead and finish off this equation by combining like terms in the denominator. So I see that I have a 9 and a 1. I can go ahead and put those together. So I end up with x plus 3 in the numerator, and my denominator becomes x squared plus 6x plus 8. So looking at this final equation right here, I have to find the domain of this equation. And we have to pay attention to both the numerator and the denominator, because in the numerator, I have a radical. So this cannot be negative. So cannot be neg. And then I also have to pay attention to the denominator, because in the denominator of a fraction, I can never be 0. So we're going to start by working with the radical, and I'm going to set the radical equal to 0. So we actually don't need to rewrite the radical because we're not actually worried about the radical. We're just worried about what's inside the radical. So I'm going to go ahead and set that equal to 0. So I'm going to say x plus 3 equals 0. And then I'm going to solve for x. So I subtract 3 from both sides, giving me x equals negative 3. And now this is where you need to make yourself a little t-table so you can figure out when this equation is negative, either above or below negative 3. So I'm going to go ahead and make myself a little t-chart. And I'm going to write out some values. So these are my x's, these are my y's. We solved for negative 3, and we know at negative 3, this part of the equation equals 0. So now I'm going to look for numbers smaller than negative 3. So I'm going to go with negative 5, and a number that is greater than negative 3. And I'll go ahead and go with 1. So if I plug negative 5 into this equation right here, I get negative 5 plus 3, which gives me negative 2. So I know at negative 5, my y value is negative. And now if I plug in 1 to this equation, I get 1 plus 3, which gives me positive 4. So I know at 1, I get a positive number. So in this situation, if I go below negative 3, I end up with negative values. But if I go above negative 3, I end up with positive values. So now that we figured this out, I'm going to say that x has to be greater than or equal to negative 3. Because remember, since my radical is in the numerator, I'm allowed to equal 0, but I just can't be negative. And I know at negative 3, this equals 0, but above negative 3, this gives me positive values. So that's why x can be greater than or equal to negative 3. Now, the second thing we have to look at is the denominator. The denominator cannot equal 0. So again, I'm going to set this equal to 0 to find out at exactly what x values the denominator does equal 0. So I have x squared plus 6x plus 8. And I'm going to set this equal to 0. Immediately, when you see a polynomial set equal to 0, you should be thinking, I got a factor. So we're going to go ahead and factor out this equation. And remember, you need to find two numbers that are going to multiply to give you 8 and add to give you 6. So I know if I multiply 2 by 4, I get 8. And if I add 2 and 4 together, I get 6. So those are my factors. X plus 2, x plus 4. And now I have to set each individual factor equal to 0. So x plus 2 equals 0 and x plus 4 equals 0. So x here is going to equal negative 2 and x here is going to equal negative 4. I know at this value and at this value, my denominator equals 0. So my x values cannot be negative 2 and negative 4. So I'm going to go ahead and write out a number line to put this information on there and this information on there. And we're going to finish by writing out our domain. So this is my number line. And I'm going to go ahead and label all this information. We found negative 4 as one of our x values. We found negative 3 as one of our x values. And we found negative 2 as one of our x values. And then, of course, as you go towards the right, you're headed in the positive direction. And as you go towards the left, you're headed in the negative direction. So I'm going to write that out as infinity. So if we go this way, we're headed to negative infinity. And if we go this way, we're headed to positive infinity. And now we have to include some symbols on our number line to help us out. So remember we said we cannot equal negative 2 and we cannot equal negative 4 because that's going to make my denominator 0. So I'm going to put little x's over those values. So I cannot equal negative 4 and I cannot equal negative 2. And then we're also going to include our inequality right here. So I said for the numerator, x has to be greater than or equal to negative 3. So I know greater than or equal to means going to the right. So I'm also going to include that. and I'm going to show that in green. It's going to go this way. So it can equal negative 3, so I'm going to put a solid dot there, and it's got to be greater than negative 3. But really quickly, I'm going to break the line right here, because remember, we still can't equal negative 2, okay? So in this situation, after I place everything onto my number line, I can see that negative 4 doesn't even matter because negative 4 is less than negative 3. So I can't even include negative 4. So my domain is essentially going to start at negative 3. So I'm going to start writing that out. My domain's going to start at negative 3, and I'm going to use a bracket because I can include negative 3. And it's going to keep going to the right until I get to negative 2. And that's where I'm going to see my first break. So I'm going to write that out. It can go to negative 2, but it cannot equal negative 2. That's why I'm going to use a parenthesis. Because if I plug in negative 2 into the denominator, into this denominator, I'm going to end up with 0. And I cannot get 0. So again, I'm going to pick up at negative 2, and I'm going to head to positive infinity. And remember, you always use parentheses for infinity. So my final answer for this question is my domain goes from negative 3 to negative 2, and then from negative 2 to infinity. So when you have a question that asks you to find the domain of a composition of function, you want to start by composing the function like we did right here, cleaning up the function, and then once you do that, you want to take a look at your final answer and ask yourself if you got to check any of the 3 rules. Here we had to check 2 of the rules. My denominator couldn't equal 0, and my numerator couldn't be negative. Once we figured out all of that information here and here, I made a number line and I put together all of my information to write out my final answer as the domain in interval notation.